Hello, we'll be going over section 4.2 inverse functions. Our objectives are one, to determine if a function is one-to-one, and second, to find inverse functions. A one-to-one function. When subtraction is introduced, it is explained as the opposite of addition. When division is introduced, it's explained as the opposite of multiplication. In this course, we have studied numerous functions, including linear, quadratic, polynomial, and rational functions. This section will discuss the idea of inverse functions, two functions that are opposites of each other. Not every function has an inverse function, so we begin our discussion with the concept of what trait a function must possess in order to have an inverse. Recall that the definition of a function is that every input has exactly one output, and we can test this by using the vertical line test. For a function to have an inverse that is also a function, the original function must also have exactly one input gets mapped to each output. A function that has this trait is said to be one-to-one. Definition. A function is one-to-one, often written as 1-1, which means one-to-one, if any two different inputs guarantee two different outputs. Just as we use the vertical line test to test for functions, we test the horizontal line test to check if a function is one-to-one. So just to emphasize this, in order for something to be a one-to-one function, it first has to be a function in order to be a one-to-one function. So it's a special type of function. Remember, for a function to be true, it needs to pass the vertical line test. And for a one-to-one function to be true, it needs to pass the horizontal line test. So in order for a function to be a function that's one-to-one, it needs to pass both. The result of the entire discussion in this section so far is that checking to see if a function is one-to-one will be the first step when discussing inverse functions. Let's consider a small sampling of the function that has been studied in the course to discuss the concept of one-to-one functions. Linear functions. Your y equals mx plus b, your lines. We begin our study of functions with the study of linear functions. Consider the two functions below from chapter 1. So we see here, we have two linear functions or two lines. No horizontal line can be drawn that will intersect either of these graphs in more than one point. So each is a one-to-one function. This will be true for any linear function that has a positive or negative slope. The only linear function that is not to 1 is a linear function with a slope of 0, the graph which has a horizontal line. So here we see that we have these lines, and no matter where I draw a horizontal line, it only crosses our graph once, right? So therefore, because it is a function, but because it passes also the horizontal line test, it's a special kind of function. It's a one-to-one function because they pass the horizontal line test. Quadratic functions. The graph of every quadratic function is a parabola that opens upward or downward. Consider the two functions from chapter 1. So we see these two, they're functions because they pass the vertical line test, right? So yes, they're functions, but are they one-to-one functions? We see that when we draw a horizontal line, it crosses our graph in more than one spot. So therefore, they're not horizontal. They're not one-to-one because they fail the horizontal line test. Since a horizontal line can be drawn that will intersect the graph at 2 points for each of these graphs, neither of these functions is one-to-one. Because a graph of every quadratic function is a parabola, no quadratic function will be one-to-one. Polynomial functions. Consider the functions from chapter 2. All right, so we have this polynomial function, and we only need to fail once. I mean, yeah, if we draw it from a point, a peak, it passes a horizontal line test, but it only takes one line to fail it. So we see here it fails the horizontal line test. Since any horizontal drawn below the y-axis, below the y-intercept, will intersect the graph more than once, the function is not one-to-one. If we recall, our graphing of polynomial functions was largely based on finding the x-intercepts. If a polynomial function has more than one x-intercept, it will fail the horizontal line test, because the horizontal line of the x-axis would hit the graph at more than one point. The only polynomial function that we will study in this section regarding inverses will be translations of parent polynomial functions. Consider your rational functions. Consider the two functions from chapter 3. So we have these two functions here. Because we can draw a horizontal line at almost anywhere and hit the graph of f of x at more than one point, it is not one-to-one. So we do here, we pass it at 2 points. We do it here, we pass it at 2 points. For g of x, which is our second one, any horizontal line will hit the graph no more than once. The function is one-to-one. So this one we see, we draw many horizontal lines and they only cross once. So this one is one-to-one. In summary, we must consider the graph of a function and we'll use the horizontal line test in order to determine if a function is one-to-one. All right, now the first part was how to find that something is one-to-one using a graph. Now we'll move on to inverse functions. Now that we understand the concept of a function being one-to-one, we can begin to explore the topic of inverse functions. Definition. Two one-to-one functions, f of x and g of x, are inverses if and only if their composition equals x. So just to remind you of the composition, I always write the formula. So if we see f composed of g, that means in my function f of x, I'm going to plug in my entire g of x, and vice versa. In my function g of x, if it's in different order, I'm going to plug in f of x for every x. So if this is so, it's one-to-one if my answer somehow magically equals x. And that's what we're looking for. If it's not x, it's not one-to-one. If it is, that's cool. We can say these two functions are inverses of one another. Example 1. Determine with the function if the one-to-one functions f of x equals 5x minus 2 and g of x equals 1 over 5x plus 2 are inverses. All right, so let's do this algebraically. So we first want to plug in my function g of x into my function f. So I'm going to take my g of x and plug it into every x in f. So we have 5, and then for x, we're going to plug in my function g minus 2. If this is so, things will work out really nicely. So here we're left to distribute that 5 to each one. 1/5 times 5 gives us x. They make 1. And then 5 times 2 is 10. We subtract 2. All right, so we're left with x plus 8. So we're done. We know that because it didn't equal x, they're not one-to-one. They're not inverses. All right, example 2 is not very pretty. So I'll let you discover this in your homework. Just know if you get an answer of x, you will know that it's one-to-one. I'll walk you through it, but it is pretty messy. So the first one's saying in my function f, I'm going to plug in my function g. So I'm going to take my function g and plug it in for every x in my function f. Right, we have this here. All right, now we go ahead and we multiply it in, and we get a common denominator. And then we're left with this here, and then things start working out really nicely to where you're just left with your x. Remember, you have to do it twice. You have to do it for f composed of g, and G composed of F. In the first two examples, we're given two functions and asked to determine if they are inverses. However, the more important skill to be learned in this section is the ability to find an inverse of a single one-to-one function. This will increase what we are able to do. Plus, it gives us an alternate way for answering the previous two example questions by simply finding the inverse of a one-to-one function and determining if it is the other function. Before we begin to find the inverse of a given function, there needs to be some discussion on the notation that will be used with inverse functions. So given a one-to-one function f of x, for the inverse, we have this notation. So when you see that -1 that kind of looks like an exponent, it's not an exponent when it's used in function notation. Function notation meaning f of x or g of x. If you see that -1 exponent, it means inverse. Given a one-to-one function with a different name, such as g of x, we write the inverse as g inverse of x, and we read it as g inverse or the inverse of g. Recall example 1 above, where we found that f of x and g of x are not inverses. So what's the inverse of f of x? It is most basic level. The function f of x equals 5x minus 2 can be seen as a mechanism that will perform two operations. When any value or expression is input into f of x, the function will 1. Multiply by 5 and subtract 2. When looking for the inverse, we need a function that will undo these properties. So just to emphasize, what are we doing here? We're multiplying by 5 and subtracting by 2, as we have here. So an inverse is the mathematical opposite. So we're trying to create an equation that's the mathematical opposite of what we have for f of x. What is that function? When looking for f inverse, we need the function that will undo these two operations in the opposite order. So we need to find f inverse to add to, then divide by 5. f of x, f inverse equals x plus 2 divided by 5 does the task. Notice that f inverse of x equals x plus 2 over 5, which is 1/5 of x plus 2 over 5, is not equivalent to the function of g of x, which is 1 over 5x plus 2. It should make sense how now why example 1 found that the f of x and g of x are not inverses. For a linear function, such as f of x equals 5x minus 2, we are able to find the inverse by inspection. However, this cannot be approached when encountering one-to-one functions, such as, for example, g of x. Therefore, we'll describe a process now that can be used to find inverse functions. So that first one was really nice, right? But if you have something that's not that kind of easy to lay out, we have these steps. So these are your steps to find one-to-one functions. Inverse functions. All right, so first you have to verify that it's one-to-one. 2, change your function notation to y. So change your f of x, change that to a y. Swap your x's and y's. You want to solve for y and change the proper inverse function notation, meaning write this instead of y. Replace your y with that inverse notation. All right, let's do example 3. Find the inverse of f of x equals 5x minus 2. Since the graph of f of x is a line, it passes the horizontal line test. All right, 2, we need to change. So this is set up by steps. Step 2, we need to change our f of x notation with a y. So we have that done. All right, for step 3 says swap x's and y's. So we're going to change my y into an x and my x into a y. Now I want to solve for y, meaning I want to get y by itself. All right, so let's do that on the side. So we have x equals 5y minus 2. So let's get y by itself. So we're going to go ahead and add 2 to both sides to make that go away. So we're left with x plus 2 equals 5y. Divide by 5, divide by 5. Get x plus 2 over 5 equals y. That's step 4. Step 5, change your y into that function notation. Example 4. At the start of the section, we showed that g of x equals negative 1 over 2x plus 3 is a one-to-one function. Find the inverse. All right, step 1, change your f of x to a y. Step 2, swap your x's and y's. I'm sorry, that's step 3. Step 4, solve for y. So let's see it on the side. So I have x equals 1, negative 1 half y plus 3. Minus 3 minus 3, I have x minus 3 equals 1 half y. All right, to get rid of fractions, multiply by the reciprocal, which is 2 over 1. That cancels my number. So I'm left with 2 times x minus 3 equals y. Redistribute. 2x minus 6 equals y. Oh, I forgot that negative. So just add a negative there. All right, so we're left with negative 2x plus 6 is our answer. Lastly, we change that y into that inverse notation. All right, let's do example 5. At the start of the section, we showed g of x equals 3x minus 4 over 2x plus 1 as a one-to-one function. Let's find the inverse. All right, so first we want to replace g of x with y, which we have here. Then we want to swap our x's and y's, so we swap those letters. All right, now we want to solve for y. All right, so we want to multiply both sides by our denominator so that I can cancel. And then we're left to distribute. So we're left with 2xy plus x equals 3y minus 4. I want to get our y's together. So how can we handle 2 copies of y when solving for y? We first need to get our y's together into a single, and then we can factor out a y into one side and then factor out a y. All right, so let's get our y's together. So that means I have to move that y, minus 3y, and get this x out of the way, so minus x. And we're here. Now we see how we have a y for each one. We can now factor out a y. All right, this gets our y into one position so that we can divide both sides by our other factor. So we divide to both sides, and we're left with y equals negative x minus 4 over 2x minus 3. Lastly, you change your y notation to function notation. One caution at this point, when solving for inverse functions, it is common for multiple people to find several equivalent versions of the same inverse function, often because variations of the choices taken when solving for y in step 4. Before considering an answer incorrect because it does not match another person's answer, make sure to check if either or both answers can be manipulated or simplified to math. All right, example 6. Determine if each of the following functions is one-to-one. If the function is one-to-one, find its inverse. All right. So A, we have p of x equals x squared minus 4x plus 3. Is it one-to-one? Oh, we have a quadratic. We talked about quadratics, right? A quadratic function whose graph is a parabola, and we saw that all parabolas do not pass the horizontal line test. So it does not have an inverse function. What about B? The square root of x plus 1 minus 5. A translation of the parent graph, square root of x, shifted 1 to the left and down 5, gives us this answer, right? And we see that it passes the horizontal line test. it's 1-to-1 and passes the horizontal line test, we can go ahead and try to find an inverse. So first step, we change f of x to a y, then we swap our x's and y's, and then we want to solve for y. To do so, let's get y by itself. So we subtract 5 to both sides. Add 5 to both sides. And then we want to do that square value, that square root. So we square both sides. And lastly, we subtract that 1. So we're left with y equals x plus 5 squared minus 1. So that is our inverse function. Before we move on, there is one technicality that must be discussed with the example. We find the inverse function of the two functions are inverses of each other, so both of the function inverse must be 1-to-1. We know that the inverse is a quadratic with a parabolic graph as follows, right? We have a square. Square means parabola. The graph of the inverse, Q inverse of x, now passes the horizontal line test. So what can we do about the situation? It is good to note the pair of inverse functions and inverses in every possible way. Most importantly here, the domain of one is the range of the other. Consider the graph of Q of x. What's our domain here? What can x not be? Well, we see that x plus 1 has to be greater or equal to 5. Greater or equal to 0, right? Because they can't take the square root of a negative number. So we subtract 1, x has to be greater or equal to negative 1. I think there's a typo here. We see that the range is negative 5 to infinity. Knowing that this must match the domain of the inverse, we restrict our domain. So the trick here is you have to check the domain of your original function. So what we're saying is our function has a domain and a range, right? The inverse function is going to have a domain that used to be our range from our other function. And it's going to have a range that used to be our domain. And so those two values swap when we're talking about an inverse and the original function. All right, so that's it for this section. If you have any questions, feel free to email me or post on our discussion board. Thanks.